Hello everyone, welcome back to my channel. My name is Vamsi. In this video, we will walk through the machine learning project where I predict real estate price in Bengaluru using the Python real data set. This is a part of the data mining and the data warehousing course. It shows we can use structured data to build the smart models for real estate problems. Let's go into it. We can see overview of our project here. We can enter the square feet areas and number of bedrooms and bathrooms and location, and then we click on estimate. We get the result of how much price of that square feet area in that particular area, square feet land in that particular area. Next we can go to our overview of our data set. This is our data set. We have nearly 13 13,000 rows and 9 main columns. In There are important features: location, total square feet, size, and bath prices in lakhs. Now we can go to our models. Here we importing the libraries which are used for our project: NumPy, Pandas, and Matplotlib, and Seaborn for the visualization, and scikit-learn to train our models. We load the dataset into our data frame df1. Initial your size is 13,320 records and 9 columns. Uh, if you drop in null values, you half of the records, or you lost half of the records. So instead of dropping records, uh, we can add using bin values or min-max normalization. You can use any methods to replace the null values. In the above total square feet, you can observe here in this total square feet range. There are some values in this range, like lower boundary, upper boundary. We can convert those into numerical by uh, taking average of minimum and maximum values in this land. There are other cases such as 36,400 square feet meters, which can convert it into square feet using unit conversion. Okay, here society we have 5,500 null values. You can fill that 5,500 null value using bin mode values. Here we observe the we can fill with bin mode values and median values of the bath column, and we converting the total square feet into numerical, like this range data into numerical data. After removing null values, we can observe there is no null values in our data set. You can find the unique values in our data set by using aggregated function group by. I draw blocks for box plot for the uh, every column to the output column to show the relation between every column and the output column. How much of effect on the output column. Here we observe the balcony is less effect on the price, because there is a less slightly difference between balcony versus price, and another column is, here we observe area type versus price. Uh, Almost every data is on the below 500 price, so it cannot affect the price and availability also. So we less affected on the output variable, so we can drop that columns. After dropping, your data frame is consisting size, total square feet, bath, and price, BHK values. You can draw the correlation map. Based on correlation map, high correlated columns can be dropped. That means both are showing same variation, so we can drop one of the column from those data frames. And here you can saw the correlation map of total square feet, bath, price, and BHK. Next, we can move to okay. In size column, you can find the how many unique values. Like here, see, we have two type values. One is BHK values, another one is bedroom. So we can convert those both into. We can remove the BHK and bedroom and place them as a integer values. Applying lambda function to for size. Wait, wait some. Okay, after that, we show a head, and in this we can drop the where a house which more than 20k land, more than 20k BHK value. You can saw here like 27 baths and 40 baths. We can drop those values. Here we converting the total square feet value by token 1 plus token 2 by 2 to converting into range values into numerical values. After converting, you can observe the total square feet. There is no range values in this. We converted into numerical values. We get the location value, adding new feature price for square feet to pre-processing purpose. This is called feature engineering. Price for square feet. How to calculate price per square feet? Price into lakh DF for total square feet. You are finding the unique values from the location. After that, we are finding the how many unique, how many points in each location. If less than 10 locations, we can consider there as other. We can observe, we plot here to the graph for that one. This is the top 20 cities, top 20 locations by number of listers in Bangalore. Okay, here we extracting less than location stats are less than 10. Uh, if we are applying dimensionality reduction by any column having less than 10 data points, uh, we should meet them at the other location. In this way, category can be reduced by huge amount of. Later, we can use one hot encoding to help using favor dummy columns. Uh, we are applying to here forming data frame 4 to removing uh, adding others for the less than 10 data points of the location. We can observe the here size location. Some are others there. Outlier removing using business logic. Here business logic is if total square. Here a business logic is for suppose we take 2 BHK apartment, the minimum required is 600 square feet. If we have 400 square feet, they are they are not suitable for the 2 BHK 2 BHK houses. So we remove the outliers which is not reading our business logic. Like we read minimum 300 square feet for the 1 BHK apartment, which is if we have a square feet less than 300 for 1 BHK, we can remove those rows. After dropping, we can observe 13,000 records are converted into 12,000 records. This is now we can drop the outliers by using standard deviation and mean. Here the code for the uh, removing outliers using standard deviation. outliers removing standard deviation less than square feet for price, standard deviation minus mean, standard deviation plus mean. We observe here before limiting outliers. This is a graph. We have data points, outlier data points at the uh, 3000. After removing, the outliers are removed. So square feet for area is at 15,000 only. Th- This is red graph showing the outliers at 3,500 price and at total square feet area 5,000. After we removing those outliers, we can observe the outliers are removed, that they are in this range 2,000 price and total square feet at 30,000. Okay. Okay, in this we are using another logic for the removing outliers. If suppose we take two bedroom flats and three bedroom apartments, uh, some areas they're showing two bedroom apartment is more cost than the three bed apartments. So business, our employee, so we remove the two bedroom apartment price greater than the three bedroom apartment in that particular location. So we can suppose we take the plot, scatter plot for the Rajaji Nagar. We can observe these blue points are the 2 BHK flats and these plus points are the 3 BHK plot. We can observe 2 BHK plots are more price than the 3 BHK plots. So we can apply outliers remove by removing which are 2 BHK flat price greater than the 3 BHK flat. S- So he can is another plot for the Hebel area. Hebel area here we can observe the 2 BHK flats are higher cost than the 3 BHK flat. So we can remove the after removing we can observe scatter plot. Here we observe 2 BHK plots which are higher than the 3 BHK flats. We remove those outliers and we plot the scatter plot. We observe all 2 BHK plots almost or less than the 3 BHK plots. We, we draw the price for square feet, count the how much price is there for the price for ground feet, and after that you count the how many unique values in the bath column. We can remove the where bathrooms are greater than the bedrooms. It is not. We can observe real life. It's not possible. So not useful for the more bathrooms than bedrooms. So we can remove where more bathrooms than the bedroom as a outliers. After removing using business logic to convert with you, we have four bedrooms home. Even if we have four bedrooms, all four bedrooms plus one guest bathroom, we can have total bed one maximum. Anything above that is outer layer. So we can remove outer layers. After removing outer layers, we get 7,300 records. You can observe now. After pre-processing, we add the column of price per square feet. We removing this column. For, after removing in the linear regression, you cannot process the categorical data in this location. So the location column is categorical. We can convert by using one hot encoding. It can provide the dummy columns for each unique values in this location. Is provide the at least it provide 120 columns here, 126 columns. Okay. After that, we drop the last column for to remove the conflict in one hot encoding. So if you don't drop the last column, it become conflict in one hot encoding. Okay, we drop the price values here. So here we building the model. After df.11 shape, we are building the model. Wait some time. Okay, sorry for the interruption. We can continue from where you start. Okay. We completed the R. Okay, now okay, welcome back. Now we completed the all pre-processing here. Now we go to model building. So testing that this one is training data. We can split the output variables and independent variables and dependent variables. Independent variables are stored in x column, x variable, and output are stored in the y variable. From sklearn, we can import the train test underscore split to split our train data test data into 80% for the training and 20% for the testing. We are importing linear regression. After linear regression, we fit the model using a fit and finding the accuracy for the linear regression model. We get accuracy at 79% model, 79 for the linear regression. So we can try another models like we can try another models like lasso, decision tree, gradient decision tree. Which one is get our better best accuracy? So based on that, we can select that model. For that, we can use the GridSearchCV. GridSearchCV is where we pass the parameters to the GridSearchCV. How many models on the data set? It can train the all models and give the which one is best. It give the accuracy of all models and which one is best for the our training model. So this is a code for GridSearchCV. This is here scores. After that, we get after model training, we get the models best score and best parameters. Here, linear regression giving 84% score accuracy and lasso giving at 0.69 accuracy. Decision tree regression decision tree given 0.75. So linear regression is giving best accuracy. So we can use a linear regression. After that, we can predict some of columns which give how much is predict correctly based on. We can we can design a website for that one. Here after that, we give building a one function for the one hot encoding. We are converted the single column to the multiple columns for the regression is because of its categorical data. We cannot process that one. So we created the columns. So based on values in this X model, we can based on the location index, we can place that one as one remaining as a 0. After we are returning the predicted value for that predicted value for the given query. Here we are calling the function. We are passing the area location and square feet, number of bedrooms, number of bathrooms. After that, it returns the lakhs values in lakhs. So we can observe here we get 87 lakhs. So predict another query we can pass. We get the 163, 169 169 lakhs. We are importing pickles to export our file. After that, I will create the website. So this is our model. Now I can show you a demo of the our website. This is our website. We can select here area and BHK is 3. Number of bathrooms is 1. Square we have select here uh, how much which location we want. Then we can click on estimate. We get the lakhs here. How much of cost it take for the square feet area in this particular location. We can change this location and estimate it. We can get. So based on that, this is our project. We have any doubt, we provide the blog below the description link and code to YouTube video. If you have inquiries, write comment on our comment below. Thank you.